Problem 1. Design a cast iron bevel gear drive for a pillar drilling machine to transmit 1875 watt at 800 rpm to a spindle at 400 rpm. The gear is to work for 40 hours per week for 3 years and pressure angle is 20 degree. Given data: P is equal to 1875 watts, N1 is equal to 800 rpm, N2 is equal to 400 rpm. Gear life is equal to 40 hours per week for 3 years. Alpha is equal to 20 degree. To find, design a bevel gear drive. Solution. Step 1. Gear ratio I. I is equal to N1 by N2. So N1 800, N2 400. The I value is 2. Reference angle. So tan del 2 is equal to I from the PhD data book page number 8.39. Del 2 is equal to tan inverse of I. Substitute the I value, find out the del 2 answer is 63.43 degree. Del 1 is equal to 90 degree minus del 2. So del 1 is equal to 26.57 degree. Next, step 2. Material for pinion and gear. From the PhD data book page number 8.5 from the table 7. Cast iron grade 35 heat treated is selected. Sigma U is equal to 35 kgf by mm square. So we change into Newton per mm square. Sigma U is equal to 350 Newton per mm square. Next, step 3. Gear life in hours. 40 hours per week into 52 weeks into 3 years. So gear life in cycle N is equal to 6240 into 60 into 800. So the N is equal to life in cycle N is equal to 29.952 into 10 to the power of 7 cycles. Step 4. Calculation of initial design torque MT. Design MT is equal to calculated MT into K into KD from the PhD data book page number 8.44. So MT is equal to 60 into P divided by 2 pi N1. Substitute the values and then find the calculated MT 22.38 Newton meter. K into KD is equal to 1.3 is assumed. So design MT is equal to 22.38 into 1.3. So 29.095 Newton meter. We change into Newton mm means 29.095 into 10 to the power of 3 Newton mm. Step 5. Calculation of EEQ, design sigma B and design sigma C. First one, EEQ from the PhD data book page number 8.14 from the table 9. Sigma U is greater than 280 means EEQ value 1.7 into 10 to the power of 6 kgf by centimeter square. We change into Newton per mm square means EEQ is equal to 1.7 into 10 to the power of 5 Newton per mm square. Next, design sigma B from the PhD data book page number 8.18 table. Design sigma B is equal to 1.4 kBl divided by n into k sigma into sigma minus 1 for rotation in one direction. KBL from the PhD data book page number 8.20 from the table 22. KBL value is taken 0.8816. Next, K sigma from the PhD data book page number 8.19 from the table 29. K sigma value is 1.2 for cast iron. N is equal to PhD data book page number 8.19 table 20. So n is equal to 2. Sigma minus 1 is equal to 0.45 sigma u from the PhD data book page number 8.19 table 19. The sigma minus 1 value is 157.5 Newton per mm square. Design sigma b. To apply all the values, finally we get the value of design sigma b 80.9 Newton per mm square. Next, design sigma c. From the PhD data book page number 8.16. Design sigma c. The formula is Cb into Hb into KCl kgf by centimeter square. Apply all the values, find out the design sigma b answer 409.8 Newton per mm square. Step 6. Calculation of cone distance capital R from the PhD data book 8.13 from the table 8. Capital R greater than or equal to psi y root of I square plus 1 into cube root of 0.72 divided by psi y minus 0.5 into design sigma c the whole square into e into design mt divided by I. Psi y is equal to PhD data book 8.15 table 13 is taken. Psi y is equal to 3 assumed roller bearing. So apply all the values, find out the capital R is greater than or equal to 50.2 and round off 51 mm. Step 7. Assume Z1 is equal to 20, Z2 is equal to I into Z1. So we get the answer of Z2 40. Next, step 8. Calculation of transverse module M. From PhD data book page number 8.38 table 31. Cone distance or formula is R is equal to 0.5 mt root of z1 square plus z2 square. So we find out mt. Substitute the values and then mt answer is 2.28 mm. To round off the value of mt from the PhD data book page number 8.2 to round off the value 2.5 mm. Next, step 9. Revision of cone distance capital R. From the table 31. R is equal to 0.5 mt root of z1 square plus z2 square. Substitute the values and find out R value is 55.9 mm. Step 10. Calculation of B, MAV, D1AV, V and psi y. First, to find out B. From PhD data book page number 8.15 table 13. Psi y formula is R by B. To rearrange the formula, B is equal to R by psi y. Substitute the R and psi y value. Finally, we get B value 18.63 mm. Next, MAV from PhD data book page number 8.38 table 31. The formula of MAV is mt minus b sin del 1 divided by z1. Substitute the values and find out MAV is equal to 2.083 mm. Next, D1AV. D1AV is equal to MAV into Z1. Substitute the MAV and Z1 value. So D1AV is equal to 41.6 mm. Next, V. V is equal to pi D1AV into N1 divided by 60. Substitute the D1AV and N1 value. So pi into 41.6 into 10 to the power of minus 3 into 800 divided by 60. The V answer is 1.745 meter per second. Next, psi y. Psi y is equal to B by D1AV. So substitute the B and D1AV values, then find out the psi y is equal to 0.447. Next, step 11. TS quality, IS quality, assumed 6 preferred quality. Next, step 12, revision of design torque, MT. So, design MT is equal to calculated MT into K into KD. So, K is equal to 1.1 for B1 D1 AV B less than or equal to 1 from the table 14 from page number 8.1. KD is equal to 1.1 for highest quality 6 conical gears up to 3 meter per second. Table 12 from PH data book 8.12. So design MT is equal to 22.38 into 1.1 into 1.1. So design MT is equal to 27.1 Newton meter to change into Newton mm. So design MT is equal to 27.1 into 10 to the power of 3 Newton mm. Next, step 13, check for bending. Sigma B is equal to 0.7 or root of I square plus 1 into design MT divided by R minus 0.5 B the whole square into B into MT into Y V1 is less than of design sigma B means design is safe. So Z1 is equal to 20. So Y V1 is equal to 0.389. Substitute all the values in sigma B formula and finally we get the answer of sigma B is 141 Newton per mm square is greater than of design sigma B. Hence design is not satisfactory. Now we will try with increased traverse module 3 mm from PhD data book referred 8.2 page number. Repeating from the step 9 again. So MT is equal to 3 mm, capital R value find out 67.8 mm for revision. B is equal to 22.36 mm for revision. MAV is equal to 2.5 mm for revision. D1AV is equal to 50 mm for revision. V is equal to 2.094 meter per second for revision. Psi y is equal to 0.447 for revision. Design MT is equal to 33.24 Newton meter. So now finally we get sigma B is equal to 58.3 Newton per mm squared for revision is less than of design sigma B. Hence the design is safe. Next, step 14. Check for VS strength from PhD data book page number 8.13. The formula of sigma C is equal to 0.72 divided by capital R minus 0.5b root of I squared root I squared plus 1 the whole square divided by I into B into EQ into design MT is less than of design sigma C means hence design is safe. So now substitute all the values of sigma C formula, find out the sigma C final answer is sigma C is equal to 439.3 Newton per mm square is less than of design sigma C, hence design is safe. Next, step 15. Calculation of basic dimensions of pinion and gear. Now, first find out traverse module. Traverse module MT is already finded. MT is equal to 3 mm. Number of teeth Z1 is equal to 20, Z2 is equal to 40. Pitch circle dia D1 is equal to MT into Z1. So substitute the MT and Z1 values. So finally we get D1 is equal to 60 mm. D2 is equal to MT into Z2. Substitute MT and Z2 values and find out finally D2 answer is 120 mm. Next, cone distance. Capital R is equal to 67.08 mm. Face width small b is equal to 22.36 mm. Pitch angles del 1 is equal to 26.57 degree. Del 2 is equal to 63.43 degree. Tip dia TA1 is equal